Beep. Okay, first and foremost, I absolutely hate this. I love multiplying polynomials because I find it fun and easy, but I hate doing the geometric versions of multiplication. Gisela multiplied 342 by 23 as follows. Oh my gosh, why would you make it so hard on yourself? But hey, whatever. She said there's 3 100s, 40s, and a 2. There's 20 and a 3. So she multiplied 20 times 3, 6,000. 20 times 40, 800. 20 times 2 is 40. 3 times the 300. 3 times the 40. 3 times the 2. Really, what they did is they are distributing. They're distributing each part. The hundreds, the tens, and the ones place. So I do love that. The key here, though, is now we're going to combine by adding diagonally. 6,000. This is 1,700. This is 160. This is 6. So add these all together, and that gives me 77, 78, 66. Okay? Can you explain what she is doing? What's her final answer? Most of you have done multiplication like this before because it's the new way of math. Well, what happens when we've got something like this? Well, I'm going to go back up because I do that. Actually, no. So we've got 3x squared, a 4x, and a 2. And at the top, we've got 2x's and a 3. And we multiply. 2 times 3 is 6. X times x squared. So this is one of the lessons that you missed from pre-algebra. So when we have like bases, we keep the base, we add the exponents. So that's 6x to the third. 2 times 4 is 8x. X times x is x squared. 2 times 2 is 4x. 3 times 3x squared is 9x squared. 3 times 4x is 12x. 3 times 2 is 6. So if I do it diagonally, I've got 6x to the third. This is plus 17x squared. This is plus 16x plus 6. Multiplying a trinomial by a binomial, I end up with a monomial to the fourth, or a fourth, I guess, what's it called? There's a name for it, but there's 4 terms. It's a 4-term monomial. Okay? Now, do I always want you to use this geometric design to do it? No. Am I going to do it for this one? No. Because this lesson is all about, this. We want the distributive property. That's what we want to use. So, I'm going to show you the way that I personally would do it. Not saying this is the only way. This is the way that I like to do it. If I had one term smack dab in front of the parentheses, I would take 3x squared and multiply it to everything. If I just had x, I'd take x and multiply it to everything. If I had -1, I'd take -1 and multiply it to everything. So here's what I do. I put breaking points in between the term and the sign. Because now I know that I have to take 3x squared and multiply it to the whole thing. What else do I need to take? I need to take a positive x and multiply it to the whole other thing. And I need to take -1 and multiply it. And you say, Mr. H, this is difficult. Yeah, it's not. It's just a lot of work. 3x squared times x to the fourth is 3. Like bases, add the exponents. 3 times -2 is -6. X squared and x to the third. Positive 3x squared. I've only done the first one. Plus, this is 1, x to the fifth. Why x to the fifth? Because every exponent, or every number, variable, whatever, has an exponent of 1 if it's not shown. Again, hopefully you watch those pre-algebra videos. Multiply here, that's -2x to the second, plus x. Last but not least, negative x to the fourth, positive 2x, minus 1. Okay, Mr. H, now what? Well, now we combine like terms. So let's start doing some colors. Do I have any x to the sixths? No. That's my largest degree. It comes first. The next one is x to the fifth. Do I have any other x to the fifths? No. So it comes down. X to the fourths. Do I have any other x to the fourths? No. So it comes down. Let's switch colors. Do I have any other x to the thirds? No. So it comes down. Oh, but wait a minute. 3x squared minus 2x squared. 3 minus 2 is 1. A positive 1, x squared. Do I need to put a plus 1 there? No. We just put x squared. There's an implied 1 there. Okay? Oh, but now we have x's. 1x plus 2x is positive 3x. Last but not least is my constant, minus 1. This is the answer to the trinomial times the trinomial. Was that a lot of work? Absolutely. Absolutely it was. But guess what? You're going to do that a bunch. You're going to do that a bunch. So when I distribute, I break it between the term and the sign. So this gets multiplied, this gets multiplied, and this gets multiplied. So I'm going down. I guess I'm going down like this. Okay. Exercise 3. The expression 10x squared plus 6x to the third is the result of applying the distributive property. 2x squared times 5, which is 10x squared. 2x squared times 3x, which is 6x to the third. Or 2 times this, or this. So what it's asking you to do, and this is part of I'm going to ask you to do it, is write down an expression such that if you apply the distributive property to your expression, it would give you the result represented. So watch what I'm going to do here. I know that I can multiply 2a by 3 and times a 7a. 2a times 3 is 6a. 2i times positive 7a is 14a squared. This is what you're doing. You're trying to break out something so that it's the distributive property. I want you to try C right now. Try letter C. So you're breaking something out. The process of reversing distribution. The process of going backwards from distributing is called factoring. When I factor, I'm really dividing a number out. So there's a bunch of ways that I could do this one. But let's just look at the numbers. I can divide 3 from both of these. When I divide by 3, 3 becomes what's called the factor. 6 divided by 3 is 2z squared. Minus 15 divided by 3 is 5z. I have now factored out a 3. I'm telling you right now that that's not completely factored. So let's factor again. 6z squared minus 15z. Can I factor out variables? Absolutely. There is a z in both of these. So z can be factored. Again, if you've watched the pre-algebra videos, z squared divided by z is just 1z. So that leaves me with 6z minus 15. Is this completely factored? No. So if I ask you to find the greatest common factor, you need to combine the number and the variable. The biggest number that goes into both perfectly is 3. The largest degreed variable that goes into both is just 1z. So again, 3z is factored out.
So I have no idea where the video stopped.
This, I've divided out, I factored out the 3 and the z. The 3 is the largest numerical value that goes into both 6 and 15. Z is the largest variable with degree that goes into z squared and z. When I factor it out, I'm dividing out 3z. What's left over is 6 divided by 3 is 2, z squared divided by z is z, and -5. The GCF is 3z. That's my greatest common factor. But if I want something completely factored, this is it. Okay? The reverse of distributing is factoring. So instead of multiplying into everything, we are dividing out from everything. And if you're like, what's a GCF? It's the greatest common factor. There's a bunch of them. And I don't like any of them. So, two main things. We distribute by taking each term to everything in the parentheses. So if I have a polynomial, multiple terms in parentheses, multiplied by another polynomial, multiple terms in parentheses, I take each individual term and I multiply it. I take each individual term and I multiply it. So there's a lot of steps. Factoring is the reverse of distributing, which means we are going to be dividing. Huzzah!